everyone must be. Yeah, so
A little bit louder.
fine. What? What exactly does it say? Like, if you are a frame S and a frame S prime is moving at a speed v with respect to you, and there is a point, say x comma y comma z comma t. So basically, these are the coordinates. You know what is a frame, right? At least in Galilean sense. So it just says like if this is with respect to S and with respect to the S prime, if it is x prime, y prime, z prime, t prime, it states that these four coordinates and these four coordinates are related by the transformation rule. X prime equal to x minus ut, y prime equal to y, z prime equal to z, t prime equal to t. So this is only when the velocity is in the direction of x. So this is consistent with most of the experiments people have done until electrodynamics. When people started doing electrodynamics, you must be familiar that if you consider electric and magnetic fields, and you try to solve some kind of wave equation which you get, like you will encounter this in your second semester, you will be getting a wave which travels at the speed 299792458. Fancy stuff for 3 into 10 power 8. I remember that way, it's my password. So, meter per second. So, and people have experimentally measured the speed of light, and then Maxwell said, since both of these travel at same speeds, they must be the same thing. So he said the waves of the electromagnetic waves is just light. It was all fine, but then did anyone ask the question, what is this speed with respect to? Is it with respect to you or with respect to you? So imagine you are a frame S and you measure electric fields E and B, and there is another frame S prime. What is the electric and magnetic fields you measure? Okay, maybe you might not be familiar, but this is a bit tangent. Okay, so forget about the values of E and B. You typically get a wave which moves at speed of light. And then since nobody said that with respect to what this travels, you can people have tried applying the Galilean transformation to the electrodynamic laws. Electrodynamics is just electromagnetic laws. And so to start with, the Galilean relativity has the principle that the laws of mechanics are same in all inertial frames. But if you try to apply these transformation rules, which will take you to another inertial frame, the laws of physics will turn out to be different. Note that the Galilean relativity is for laws of mechanics, but people try to generalize it for laws of physics itself. So you can have three possibilities. One possibility is that the principle of relativity, which is this Galilean principle of relativity, holds only for mechanics, but not in electrodynamics, electromagnetism. We will get this conclusion because if we assume that from this you know that the velocity is transformer d prime equal to u prime equal to u minus v, right? But then if it transforms like this, assume that there is a frame in which the speed of light is c. According to these laws, there will be a frame which is moving with speed v, where the speed of light is c minus v. But experimentally it has never been observed. One reason might be that at that time v might, like c is very high, so there might be errors. But then, like, when Maxwell showed his thing that c equal to 299, 3 to 10 power 8, there is no way to have a transformation such that it is c minus v, because in all the inertial frames, you end up solving the wave equation and get the speed as c equal to 3 into 10 power 8 meter per second. So from this, like, technically the principle of relativity in Galilean sense, before Einstein, is that laws of physics is same in all reference frames, inertial reference frames. It also means that there is no special inertial frame, right? Because laws of physics are same in all reference frames. But if you try to do this transformation, you will be getting a different law of electromagnetism. Yeah. So there is a possibility that this principle holds only for mechanics, not for electrodynamics, which says that in electrodynamics you have a special inertial frame in which the speed of light is c. That particular inertial frame is called the ether, and this is the ether hypothesis, where you, like, there is a frame in which this is c, and in a different frame, like, the speed of light is c minus v. You can also have a possibility where principle of relativity, I'll write it as, is true in both mechanics and electrodynamics. But the equations given by Maxwell are wrong. So don't worry too much about the Maxwell's equations. They are just the potential and magnetic potential, electric potential you wrote in your school in a fancy way. So these are wrong and these need some corrections. What kind of correction will you give to Maxwell's equation such that this thing holds in electrodynamics? So this, you get this kind of speed. So technically, when you want to speak about relative velocities in electrodynamics, what can you speak with respect to? The source, which is giving the electric and magnetic fields, but the speed of the electromagnetic wave doesn't depend on the source, right? With respect to this, according to the Maxwell's electrodynamics. So you can try to modify these equations in order such that the wave equations you get from the new laws of electrodynamics will give you a speed of light which depends on the source. People have tried that, but then they showed deviations from experimental results. So they kind of, like, not much fond about this. People still tried it till Einstein's time by giving, like, weirder modifications of electrodynamic laws. And the other option is principle of relativity is true for both mechanics and electrodynamics, but the Galilean transformations, that is the Newton's laws, which you get from these, are wrong. So to test if this is true or this is true or this is true, technically you need to do experiments and then you need to see which of these is true. So one of the experiments which is done to test like the first one is the Michelson-Morley experiment.
Right, any doubt till now? He is just telling a story, everyone understood that, right?
Yeah.
If you have any doubt, just ask.
Can you turn off the fans?
Can some of you guys like vote?
Yeah.
These benches are empty, these benches are empty. I guess you guys can. Yes, you can do one thing. You can use G01 for the next club, but the only problem is the board is not that nice. That's why we prefer doing it in the painting.
To be honest, in G01, the writing is not really visible.
Yeah, that's the problem.
And also the writings are much smaller.
I'll try to speak.
Okay.
Fine.
Some of you guys can you please like occupy the front seat? Yeah, like you guys can like sit individually in a bench.
Maximum I think it is class.
Yeah. Okay.
So, like to test the ether hypothesis, people designed something called the Michelson-Morley experiment. This says that speed of light transforms with respect to the Galilean transformations. But you can see that the speed of light is much higher than what you normally see. So how do you can you guys think of any experiment which can take in small differences and give you a results which you can see? Obviously. So people assume that there is a ether, there is a frame which is think of it like a fluid, but not exactly like a fluid. It is a frame in which the light travels at speed c, exactly c. And then we are in a frame which is moving at a velocity v. So, according to Galilean transformations, we should be moving with respect to the ether in a speed v. Or let's say the ether moves with respect to us also. Now the setup is that so there is a source of light, and this is a mirror and glass kind of thing where if you shoot the rays of light here, they go perpendicularly and they also pass through. Half passes through one, half passes through the other. And the orientation decides which way the light rays go, this way or that way. That should be obvious. So once imagine this is a source, this is a light source which emits, let's say, straight, right? A part of the light emitted by this goes here, gets reflected, and then it reaches here. Fine? Yeah. A part of that will go here, gets reflected, and it will also again come here.
Some part of the reflection
It is okay. Particle not that. Even this will go like that, but nothing is there to show what light goes here. It is a source. Light reflecting back to that doesn't do anything. So these two light rays will interfere here to give you a interference pattern. Why does interference come? Let's say this technically they call these arms of the interferometer. when does interference happen? Like constructive or destructive? Phase difference, we get it from path difference, right? So the path difference is created by these two. And like path difference and phase difference are related by the speed and stuff u. So let's say we are in a frame in which the ether drags your light with a speed v in this direction. We are assuming that the ether drags in a direction parallel to this because if we assume like the ether is a frame in the whole universe, we are always moving in rotational motion, like a very weird motion. So at least there will be two times where the ether moves like this or like the opposite way. So this velocity keeps on changing. You just need to see the change in the interference pattern if something like this exists. Right, we are constantly moving with respect to the frame. Earth moves and even sun moves.
What do you mean by the
So I told you to think about ether like a gas. You kind of like visualize, it is something to visualize that the ether is dragging.
Are you saying that ether is a frame at rest or is it moving around?
Rest and motion, okay, fine. So ether is a frame. See, you can't say if something is moving or not. Like, absolutely, absolute rest doesn't exist. Assuming that ether is a frame in which speed of light is c. If you are going to a different frame, your speed of light changes. It is like that frame causes your speed of light to change. Like, it is not exactly verbally ether dragging anything. It is just that because of the existence of a frame called ether, your speed of light changes. But then in this direction, what will be the speed of light? Like here you can just add up c plus v, in this direction c minus v. Is it?
Why? Because you're moving here, it's relative here, not in that particular direction. It should be c itself.
So light moves like this. But there is some motion because of our motion with respect to the ether, which is this way. So I'll label it properly. This is O, this is A, let's say M1, the mirror one, and it is of length L1. Right. So when going like this, it goes with a speed what?
C minus v.
We are moving in a speed v, so it moves in a opposite direction. Like the effect is opposite.
C minus v.
And when the light is getting reflected, what is its speed? Fine. So what is the assume that it starts from this point, from the mirror or the reflector at time t equal to 0. Let's say it gets reflected, like it goes there, gets reflected in time t1. How do you write time t1 in terms of L1 and c wave? Fine. Fine.
Just a second, guys. Till now, whatever has been taught to, is there any doubt or anything that you are not able to understand? Anyone? Like, see, right now, whatever he has taught, I think some of you might think it's a bit boring because it's still the initial parts of
Yeah.
it. Like, once it will start shifting gears, then you will really like it. But right now, it's still just the initial history of discovery of it and stuff like that. So, it might be a bit boring. And when things get a bit boring, you might just lose attention and skip something. So that's why we are asking you time and again. Is there anything where any one of you, like any one of you, if there are not able to understand it, or they are not infinite. Everyone is able to understand whatever is going on right now. Because it's a bit boring what is going on right now, but it's necessary for you to appreciate the thing that's coming.
Like in a perpendicular direction, we are taking the speed to be c.
No. Imagine that you are in a river which is moving and you want to go perpendicular to it. You will be going in a angular way, right? So I'll go to that.
No, actually, I was asking that we don't know in which direction the ether flame is moving with respect to us, right?
Yeah.
So we have to take two components, no? V1 and V2.
That's what I was speaking like. The earth always rotates in one direction and like the sun also moves. So like during the year, there will be a time where like the ether moves at speed v, and then the v should change, as you said. Like since the earth is rotating and moving with respect to the ether, the v should also change. So if we see a change in the interference pattern, which means the earth is moving with respect to something. I guess it is a much simplified calculation. The actual setup of Michelson-Morley is much sophisticated than this. It has like too many mirrors and stuff. So this can be written as 2L1 c by c square minus b square. Then, so what about the perpendicular? So let's say b2 by 2 and c by 2. So like this is completely vt2. If it takes time t2 to move through the whole thing, the distance travel horizontally is vt2, and this is L2. So the total distance will be 2 root L2 square plus v square t2 square. Fine. This, since speed of light is in this direction, so the total distance the light travels is c/d2, and with respect to the L2 and stuff, we have in like this form. So what is c2? Fine. Yeah. Square on both sides and you take it out. You get it. Fine. Are all of you fine with this? All of you?
It's twice of the hypotenuse, right? That LHS.
Yeah.
It's twice of hypotenuse.
Should be v square d to square by 4 now.
So I think VD
Fine.
Now, follow with
Can you come in?
we should just calculate the hypotenuse and multiply by twice, so like L2 and VD2 by 2. So
Fine.
take its hypotenuse and then
Yeah. So this will be T2. So what is the time difference between like these two paths, delta t.
We have one doubt. From which reference frame is the time t2 calculated and which reference frame the time t1 is calculated?
Earth's reference frame. Both are in Earth's reference frame.
Both are in Earth's reference frame.
Yeah.
So the light wave is reaching that point at a different time, t1 and t2.
Come again?
First ray was reaching that point time t1 and another was reaching at time t2.
Yeah. So there is technically a time difference between both the paths. Now what they did is to rotate the whole apparatus by 90 degrees. So L1 becomes L2, L2 becomes L1. You get it? So while doing this, you get it as L1 by root over 1 minus t square by t square minus L2 1 minus t square by c square. Now you take the difference between the difference of these times. Fine. So if you get any absolute minus sign, you can ignore it because it's the time difference. Doesn't matter. So like now if you assume V much smaller than C, you can approximate this to this will become 1 plus V square by C square, that will become 1 plus half V square by C square. Gets cancelled. So when you are
It's the difference between changes in time, right?
Yeah.
So the sign will be matters. The difference between change in time.
it depends on how I define it, right? Delta T1 minus delta T2. Or
Yeah, that's all.
Or
So
even-
sign matters.
even I might like, see I can't, while defining delta T, I took this time minus this. You just need that show that there is some difference of time. Like if it is the opposite, like it just depends if the fringe goes up or down. So when you change the, so it is a bit confusing because this delta t prime is related to the fringe width or and fringes, and this delta overall delta is related to the change in fringes. So when you try to rotate the apparatus by 90 degrees, you should see change in the like in the fringes. You can also try to calculate how much the fringes change by dividing it with the time period of the light waves. If you want, I can show you the calculation. Then time will be since it is an oscillating So like T will be lambda by C, and from this you get some delta n. So when you try to, this delta n is related to the whole delta. When you try to rotate the apparatus by 90 degrees, you need to see a change in fringes. This is approximately 0.4 of the fringe width. The apparatus they made, I think, can go till 0.001 times of a fringe width. So this amount of change should be really visible. But when they actually did the experiment, it was not visible. The delta n is always 0. It is that optics stuff you do in your 12th standard. There is some, this is a time difference by the time of an oscillation. It will give you like that, y equal to lambda d sine theta. So you will get the fringes n1, n2. From this you will get another fringes, and they move relative to each other when you try to rotate the apparatus. That is the delta n. One way Lorentz tried to explain this is by saying that objects moving with respect to ether shrink in the size. Lorentz contraction came before Einstein. So Lorentz said L1 actually goes to L1 not root over 1 minus beta square. Beta is V by C. Like this is not a calculation they did, but this is a hypothesis kind of thing they did. If you try to put this in your expressions, you get delta n equal to 0. I am not going into the details because of time constraints. You can read up Resnick Special Relativity for the details. Apart from this, people also made a hypothesis that like objects gets like ether is such that it gets stuck to your body or any object which is moving in the ether. So light like it will make that V go to 0 because it is like a fluid now. Like it is a very strange hypothesis. If you have that hypothesis, then you can explain all this properly. But what goes wrong is something called stellar aberration, where stars which rotate, like to see them you need to keep your telescope at an angle. If you move with respect to the ether, if you move with respect to the ether, you need to keep the telescope at an angle so that the rays come like this and not like this. If it is a telescope and if you keep it just above then because of the ether drag, instead of the rays coming like this, they might come like this and you won't be able to see them clearly. So if the ether getting stuck to objects is a true hypothesis, then this should not happen, but people observe this to happen.
How did you know the observation of this?
Astronomy stuff, I'm not sure. So is there a way to actually resolve all this? Like if you try to make this right, that goes wrong. If you try to make that right, this goes wrong. In the book I mentioned, Resnick Special Relativity, they gave a table with a lot of experiments done and the hypotheses which are proved or disproved by the experiments. So apart from special relativity, no other hypothesis has been proven true by all the experiments.
Lorentz's idea prove?
Lorentz idea of Lorentz contraction.
Yeah, does it prove?
Yeah, but he said objects which are moving in the ether gets contracted. There is no ether, so it is partially true, but not exactly like the way he said. He even gave the Lorentz transformations with respect to his hypothesis, but the inference of the transformations is not true as given by him. From the Michelson interferometer, like if you go into the details, you can actually say that in order to get the delta n equal to 0, light must be moving in the same speed in all directions, which is exactly what Einstein took as a postulate. Postulate number 1, speed of light is equal to c with respect to all inertial frames in all directions. Got it? And he retained the principle of relativity by Galileo, which says that laws of physics are same for all inertial frames. Taking these two as the postulates of the theory, we are going to build the actual Lorentz transformations. You will get GR here. Can you repeat your question again? You will see that later in the GR talk if you are interested. Yeah, but all of them are approximately 0 compared to the speed of light, right? See, even this paper moving is a non-inertial frame, but you can still apply in Newton's laws because V is very small compared to speed of light. Same with all the stuff you see, like on the earth or even in this case of the solar system. If you consider the universe and stuff, then you need to consider that effects also. Okay, so special relativity is about inertial frames. Let's give it to inertial frames. So initially Galileo took this as the only postulate and they made the transformations. Now considering these two as the main postulates, like let's construct a new transformation. T prime, x prime, y prime, z prime, a1. Even the Galilean transformations can be done in a matrix form. So I am writing this, assuming that you are familiar with matrix. So assuming that something like this is the actual Lorentz transformations of mechanics, we are supposed to get the values of all the 16 coefficients. if you are familiar with Lorentz transformations and stuff, half of them are actually more than half of them are just 0. So let's consider a like a frame transformation where the frame is only moving in x-axis with respect to us. And the typical Lorentz transformation, the typical frame motion.
So y and z is 0.
What do you mean by y and z are 0?
We won't consider y-axis and z-axis. We are only considering x-axis.
Yeah, the motion of the other frame with respect to us is only in the x-axis. You can generalize it later. So we also have a principle called principle of homogeneity where, like, if I am here or somewhere else in the frame, it should look the same. So assuming that this is like us, x, y, z. This is a frame which moves with respect to the speed v, with respect to s. If you see in the Galilean transformations, y prime, z prime, t prime, all three of them are not affected by a motion in x direction. What?
Which all are not affected by
Except x, all three directions are not affected, right? I mean,
T.
t.
Okay. Okay.
So this, like, the thing of t not being affected comes from Newton's statement where he says time is an absolute thing which runs independent of any external things. But then the question is, who told you that? Like, you let it change and then see if it comes or not. So I am also making an assumption in this calculation that both the frames have their x-axis coinciding with each other at all times, because the motion is already only in x direction. So x-axis of s and x prime axis of s prime should always be same. They are coinciding, right? What is the condition? Like, how do you write x-axis in math form? Like y equal to 0, z equal to 0. This should also imply y prime equal to 0, z prime equal to 0, because both of them should coincide with each other. In this transformation, like, let's write y prime equal to a21x plus a22y plus a23z plus a24t. Now if I make this 0 and this 0, this should be equal to 0 for arbitrary x and t, which means a21 and a24 are 0. Got it? So you make the same argument for z also. Z prime equal to 0 when y and z are 0. So these two should also be 0. Right? Now let's do the same thing for a plane rather than a line, like an axis. Consider the xz plane. How do you write xz plane? Y equal to 0 implies y dash equal to 0. So y equal to 0 should so an arbitrary y prime now will be written as a22y plus a23z. Y equal to 0 should imply to you that y prime equal to 0, right? which means this is also 0. Got it? Similarly for z, x, y plane, which gives you the z condition. Are all of you getting it? Is there a way to determine A22 and A23 using these two principles? Any of this? All of this? Should be? How?
Because T is the same, according to Newton, T is the same.
According to Newton?
T time should be the same for both.
This is like writing a modification to the Newton rules. Galilean transformations. Any doubt? So you do this using the. No, I'm only talking about y prime and z prime, right? Like only focus on A22 and A33. No x and t dependence. So technically you get y prime equal to A22y, z prime equal to A33z. Now imagine you have a meter scale in the y direction for s. Like in the frame of s, you have a meter scale parallel to the y direction with length 1 meter. So what will be its length in y prime frame?
V.
These are the transformations for y and z. A22.
But it should not be null because the laws of relation should be same for all relations. Otherwise, the name will change, we will determine that there is a different frame than the first frame. But the experience should be same in both the frames.
Partially true, but it has a mistake because even in x and t,
Yes.
you can use the same argument to say that x prime equal to x, but that is not the case.
But in that case, we know that the other frame is moving and the time can change. But
Yeah.
in this case, in both the frames, we are the observers and we are seeing when the length changes. So we can determine that the first frame was at rest and maybe it was moving with respect to this. The experience changes for the observer in this case. In x and t, it is different. We are observing the different frame.
How are those two frames different?
Like I consider the frame which is at rest with respect to me. That is a inertial frame for me. And I see another frame that is moving with a constant velocity with respect to this. Then x and t are observed where x and t will change. X prime and t prime will change.
Yeah.
That is different from me having a scale in both the frames and me being a part of that frame. And now if I am seeing the change in the length of the scales, that is a different experience for me.
How are you observing like a parameter like the scale is at rest in S frame, and if we observe from S dash frame which is moving with B, it is moving with some substance with the speed B, right? So our observer is in S dash frame and S frame, the two observers.
There are two observers.
Yes.
So let's say I am in S frame. So this is a meter stick in y direction. This is x direction. I measure this length to be 1 meter, and you are the x prime observer. With respect to you, I am moving. This is also moving. While it is moving, you measure it, and you get a value A22 according to that transformation.
Then the lengths could come different, but if like the experiment is being performed in two different frames S and S dash, then it should come same. Because the laws of physics are same in all relations.
Laws of physics are same. Lengths need not be same.
But the experiment is being performed in S frame, and I'm the observer of S frame. For me, the rod is stationary, and when I go to the S dash frame, and the experiment is being performed in S dash frame, then also the length should come same.
The rod is still
Why?
stationary. The rod is still stationary in that.
Rod is not stationary in the x prime frame.
That was what I was asking.
Yeah.
What are the observers in the frames of the observers?
In the case of the contraction of the ring, I am not a part of that frame. The rod is moving. So the experiment is different. Because the first experiment, the rod was at rest with respect to me. In the second experiment, the rod was moving. So the experiments are different. The results can come different.
The results are different.
But in this case, for A22, I am keeping the rod at rest in both the planes.
No. The rod is at rest with respect to S. With respect to S. With respect to S prime, the rod is still moving. You measure it while it is moving. Get it?
The rod in this case is the axis, right? The y-axis and the y-prime axis. The y-axis is at rest in S plane.
You have a rod parallel to the y-axis. Doesn't mean the rod is the y-axis. It has a finite length.
No, but for finding A22, we can make it to the axis.
How exactly is it different? You mean scaling of the axis?
Yes.
It is a better analogy to say rather than the axis. Saying the axis gets scaled is a messy technique. So, as like what you said will be continued later in the following logic. Where? Expression T. Can you speak a bit louder? Expression T. Huh. An arbitrary point. Did you come in the beginning of the lecture?
So the x prime is measured with respect to x prime.
X prime is?
Okay, so prime coordinates are equal in the prime.
Yeah. So one more assumption while doing this experiment is that at t equal to 0, both the frames coincide. Origins of both the frames coincide.
The prime measurements are from S prime or S?
Prime measurements are from S prime. So now that particular meter scale, you bring it to rest with respect to S prime. And as you said, with respect to S prime, it should still have a length of 1. So in this case, y prime equal to 1, what will be y? With respect to these kind of transformations. 1 by a2. So in like it is a bit confusing, but in S prime frame you have a scale moving at a speed and its length is a22. Got it? And in Y frame you have the same scale moving at speed. I am saying speed, and its length is 1 by a2. So think of it like S and S prime got interchanged. You should still be seeing the same results, which means a22 equal to 1 by a22. So a22 equal to 1, like you said.
So you are saying that in this case the same experiment is having the rod that is perpendicular to the velocity of the frame which we are observing.
Yeah.
And the length, the result should come the same. So
Yeah.
it will be 1 by a2.
Yeah. So this length in the S prime frame you measure where it is moving should be equal to this length in S prime where it is again moving, and both the lengths should be same, which gives a22 equal to 1.
Right and bias.
Math major. Okay. Lengths can't be minus 1. Take modulus.
Minus 1 if the scale was pointing in the positive y direction.
It should point in the negative.
Yeah, in the other frame it is pointing downwards.
In that case, there should be some frame.
We should see that
Like this kind of transformations are continuous transformations. So you start from something and you go on changing it. If there is a possibility for it to get reversed, since it is a continuous transformation, there is a possibility for it to go 0. Scale going length 0 is a singularity, according to Newtonian mechanics. Say you apply the same logic for Z. Y and Z are like similar stuff. So A33 is also 1. Got it? Now think about x1 and t1. X prime is given by a11 x plus a12 y plus a13 z plus a14t. Like the row multiplication. Then I told you something called homogeneity, where since the motion is not in YZ frames, you do a transformation of coordinates, not velocity, along YZ frame, you should still see the same results. Do you understand? All of you. So now what I am speaking about is a transformation where I am here. I will go here, but my velocity is still the same. So y goes to some arbitrary y prime. Understand? Need not be a velocity transformation. So even if you go to a different y, you should still see the same results. Which means x prime and t prime should not depend on y. Right? Same goes with z. So this is the coefficient of y which will go to 0. All of you, do you understand? Same with the z coefficient. Same in case with t. Half of them are just zeros and ones. Now, so all that weird matrix now just becomes x prime equal to a11 x plus do you get it? Fine. Now, both the origins are related by the velocity, right? So, with respect to this origin will be traveling at a speed. So, I told you a condition that at time t equal to 0, both the origins are coinciding. So, at time t, what will be the this origin in terms of x will be Vt. So x prime equal to 0 should go to x equal to Vt. It implies that x equal to Vt. So x prime equal to 0 is the same point in S prime frame as x equal to Vt in S frame. You get it? It's a very verbal statement of a very easy, simple math statement. Which means x prime should be written as something like x minus Vt. You understand this? X prime equal to 0 implies x equal to Vt. You get this? Which means if you keep this 0, you should get a11 x equal to minus a14t, which is equal to Vt. So the ratios will just be equal to 1. So this will just become a11 into x minus Vt Now do you have any idea to evaluate the remaining coefficients? Anyone? Fine. So till now we never used the thing that speed of light is c in a frame, right? So take a thought experiment where you have two frames at the same point. There are two frames at the same point. Like the origin of the two frames is same in the beginning. And then at the origin you keep a point source of light. This should give you a, like in S frame, it should be a sphere of light. Got it? Since the speed of light is same in all directions in S prime frame also, you should see the same sphere in S prime frame, which is moving at a speed v. All of you, do you get it? It is a so after time t, the light goes with the radius ct. Get it? So in this frame, the radius covered by the light is ct. So we write the sphere equation. Same should be with this case, because speed of light is same here also. Now plug in these equations. In this equation. X prime is given by a11 x minus vt, y prime equal to y, z prime equal to z, t prime equal to if you like insert this in that, a11 square x square plus a11 square b square t square minus 2a11 bx t plus y square plus z square equal to c square into f11 square x square plus thank you. Fine. You take this here, typical calculus. a11 square minus c square, a41 square fine.
Also, if anyone has any doubts, you can
Sure. Yeah, the light source is moving.
Okay, so like, is it two light sources? One light source?
No, it's just single light source. Yeah, so imagine the light source is fixed to the origin of S frame.
Okay.
So with respect to S prime frame, it is moving.
Okay.
Understand?
So the light source is a black one, like if we keep a torch here and we move that torch will be on the side, not in the origin of the.
At time t equal to 0. See, that is exactly why initially I drew a coordinate frame where both are coinciding, but then I separated them.
Okay, so like that sphere of light should be
With respect to S prime, sorry, S prime sphere will be moving with respect to S. But the equations I am writing for S prime are with respect to S prime. You understand? X1, Y1, Z1, T1 are with respect to the S1. Yeah. So I'll tell you. Just consider S1 frame and say the light source is moving like this. at time t equal to 0, the light source is at the origin. It emits a light like this. You think that it should move because you think that the speed of light depends on the speed of the source. See, if you consider the light emitted after some time, it will be shifted.
Okay.
I am only speaking about the light emitted exactly at t equal to 0. What are the xt terms here? Did anyone calculate? Can you all cross check this? So comparing this with the equation of this should be equal to 1. Got it? And y square, z square are same.
Yes.
We have a extra xt term. We should go to 0. So v a11 plus c square a41 a44 equal to 0. Similarly for the t square term, c square a44 square minus a11 square b square equal to c square. Fine? It's not? Oh, fine. A11 square minus c square a41 square equal to 1. C square a44 square minus a11 square b square equal to c square. A11 square plus. From this, can you solve for a11, a44, a14? 3 variables, 3 equations you can solve. So a41 square c square equal to a11 square. Got it? And you have a44 square equal to a11 square into b square by c square plus 1. Right. And also one more equation. v a11 square plus equal to c square a41 a44. If you input this here, you get v c square a41 square equal to c square a41. Fine?
First equation, A41 is y c
A41? This one?
Should have plus 1.
Ah. Minus 1.
Yeah.
So just write a44 equal to minus v a11 square by c square a41. this A44 in this equation, you will get a relation between A41 and A11 square. Again, so we have two relations between A41 and A11 square. And if you solve them, you will get you can try solving it too. Check this.
How do you reject negative? There should be no solution.
Good question. Like when you take t equal to 0, you should only be getting the positive solution because the lengths you know are positive at that time at least. Or let's say you take beta equal to 0, which means s and s prime are the same frame. You should get equality, not a counter equality. From these three coefficients we now write x prime equal to 1 by root 1 minus beta equal to v by c. I wrote it. X minus vt, t prime equal to 1 by root over 1 minus beta square t minus v by c square x y prime equal to y, z prime equal to z. These are the Lorentz transformations.
He had a general velocity instead of just the vx axis. He had a general speed. Like if he had a vx, vy, vz, he had three components. So the v that we use here would be just vx, or would it be?
No, they change because if you have a motion of the s prime in a like random direction, y and z should also change, right? So you take this and you try to generalize it to a different.
For two frames, you can just rotate the second frame so that the x-axis points towards the velocity vector on the other side.
So if you want to write the Lorentz transformation for any general frame, rotate the axis by r, write this and then rotate it back.
But that would not be possible for three frames. The rotation would be different for the third frame.
What?
If they have to consider all three simultaneously, the rotation will be different for
Let it be. You have two frames. From one to the other, you get a in general transformation. So from that to the other one also you can construct the other one, and these two will also be related by something. So it is like you define for two frames, and you can generalize it to any number of arbitrary frames.
Yes.
You get it, right?
Yeah. Why does the A41 have negative?
Why does the?
A41 have negative.
Because of this equation. A44 should not have positive negative sign because at the limit v tends to 0. You should get x prime equal to x, y prime equal to y. So that should not be negative. So the only way it is possible is A41 is negative.
Boundary condition.
Boundary condition? Okay, see. Can you replace
equal to 0, if they are same things.
Like v equal to 0, you should end up with the same.
When we solve that equation, like we related that to x square plus y square plus z square equals to 0. Can we have a different solution for like that? It need not be x square plus y square plus z square is equal to like. Can we have that minus 2x term and non-zero and that x square quotient not equal to 1? So like, can we have a different solution and the coefficient of x square not being 1 and then that minus 2x term not being 0?
No, because x, y, z, t, like they show the light sphere in S frame. So x square plus y square plus z square equal to ct square should be valid.
That should be valid. Okay, but like we are not devaluating that, but can we have like a different solution like that sort of one? With the minus 2x term quotient being non-zero and x square. So if the x square quotient is 1, then the minus 2x quotient should be 0. But if the x square quotient is like not 1, then can we have a minus 2x quotient?
You mean that x square term cancelling the 2x term? That is like we are writing this for arbitrary x and t, right? So you can always write, say,
we can vary x without varying t because x depends on t. Because if it
what you said is also there. It depends on t. But that thing should be valid for all t. And you can orient your coordinate in any arbitrary direction. So even the x should be arbitrary. See, even if you rotate the whole frame by some angle theta, you should still get the same result. So x and t are technically like, arbitrary. See, they are related by something, but even that relation needs some kind of variables. So at the end you need two variables.
Since y and z we can vary y and z. Okay.
Like from this you can write the equations for changes in x rather than the coordinates. Get it? So you write dx1 equal to, let's say this quantity is gamma. Gamma is independent of what point you are seeing in the frame. Gamma just depends on the frame.
How are x and t related?
How are?
X and t related.
So you take a point source and you are having light go to there. Right? The amount of time like goes on, the amount of distance it travels. From that x and t are related.
You are talking about this equation x square plus spherical equation.
Yeah. They are also that is the only relation you have between x and t. Technically.
But an explicit relation like y and z are also involved.
Yeah.
But that equation is in delta x and delta t, right?
Here I am
C delta t square should be more than delta x square for two equations, like for 2 points.
I am only considering one source.
Yes.
Wow. So the initial condition itself says that both of them coincide. So the x we are writing is the x travel. So that is the only possible relation we have between x and t.
Like we can treat x and t as independent parameters or not.
We can. See, technically you have only two equations and you have 4 parameters. So how many independent parameters you get? 2, right? Actually, in the case of just x square, y square, z square equal to c square, t square, you have three independent parameters. X, y, z can be independent because you take this coordinate axis, you write x, y, z, or your coordinate axis might be rotated or something. For at the end of the day, the radius should be same. X, y, z can vary like anything. They should just keep this as the constant. Not as same. So if you write dx in terms, like if you differentiate it, just take a dx part. You get gamma dx minus dt prime equal to gamma dt minus right? So you can write this in a matrix format again, right? This time I am writing dt1 as the first element of the matrix.
Guys, if someone is out, you can ask 10 questions.
Question please. In this case, I put dt in the first. You can verify this. Sorry. Thank you. Fine. So from now I am using a convention where this is x, you call it dx1, dx2, dx3, and I call it dx0. Fine. And this is a vector in with 4 elements. So I call this a 4 vector. So I denote each component with an index called mu, where mu runs from 0 to 3. Get it? So 0, 1, 2, 3. And when I write this, I actually mean the vector. Do you understand? When I write something called dx2, I mean the component. When I write something called dx mu, I mean the entire vector.
Why can't you just leave it something else?
Why can't?
Leave it something else.
Convenient.
Like dx mu, if I look at dx mu, I think of the mu's element of dx
Yeah.
instead of the whole vector.
Just think how is it different? The whole vector is characterized by all the 4 elements.
Yeah.
You
Just
are-
writing. Okay. So just writing dx mu.
So dx. When I say this, do you understand that this is
Okay.
the representation of this?
Okay.
And this is taken for granted. So whenever I write dx mu, this is a vector. And what is a vector in the first place? Don't tell me an element of a vector space. Okay. So our definition of a vector is something which transforms like a vector. Got it? And I called these two vectors. How are they transforming? Using this. So at least in special relativity, a vector is something which transforms like this.
Isn't the transformation defined on the vector? Isn't this a circular argument?
It is a circular. See, I can take up a random tuple of numbers.
Yes.
Let's say density, speed of light, your height and something else. How does it transform when I change the plane? Your density changes?
Maybe, I don't think so.
In this it does. Use the normal. So, but the speed of light doesn't change.
No.
Your height changes.
Yes.
So, anything which transforms like this. So we further generalize this with something called a Lorentz transformation. So this is just in the case of a transformation where you are going in x, like the other frame is moving in x direction. You technically call this some. Okay, I'll introduce it later. So dx mu prime is this vector. Dx mu is this vector, right? You are all aware of matrix algebra. So each element of this matrix is represented by two indices. Let me call this matrix lambda. Let one index be mu, one index be nu. You get it? So let me write the Can I write it like this? Sorry. V equal to 0. Can I write it like this? Each element mu will be summed like along the row with this. It is just the Aij definition written in Francis. So now I will just remove this sigma and say whenever I have an index up and down, I just sum it. You understand? It is called the Einstein summation. So let's say I have a vector mu equal to 1, 2, 3, 4. When I write mu.
I have a question.
Yeah.
Why do you use superscripts and subscripts in some cases?
I'll come there. See, when you write a normal matrix in your 11th standard or 12th standard, you write Aij. Who told you that it should be a subscript? No one.
You will confuse it with the power source.
That's why you can use like this. So this is much feasible because you will be working with a lot of summations and every time you can't write a summation if you are as lazy as me. So you define like this and you can see, like it looks easy after some time to work with this rather than the summations. And you must be familiar that mu represents like row elements and mu represents column elements. I might interchange row and column. Sure. Let it be like this, and now let's calculate something. Oh, we actually already did it. this equation we wrote is actually with in the case that the source is at the origin, right? But if you continue from these transformations and try to write dx square, dy square, dz square, dt square relation, like you have these relations between dt primed coordinates and unprimed coordinates. Now try to find out dx prime square. This is exactly what we do. Keep the index up and square at a bit up. dx dy prime square. Let's say the prime coordinates are just x bar b. Any convention of physics is. So you have dx bar zeros 1 square plus dx bar 2 square plus bar 3 square plus minus c square. Okay. So let me change something. Let me just define it as by c. Obvious reasons, like c always comes in the c dt prime, and then the dimensions will be the same when you want to work with the vector. If you want to work with a vector like this, where one element has time dimension and the rest has length dimensions, it will be confusing. Although later you will do the same thing. So you replace this vector with c. You replace this with c. Fine. And I think this goes and this comes because of the replacement. Try to calculate this in terms of dx, dy, dz, dt. All of you. Bar is just the prime coordinates and 1, 2, 3, 4 are the indices. You should get used to that because you no longer work with x, y, z, t if you go to GR at least. Why are you laughing, bro?
Again, finding the notation of intermediate by going into the by making it to go to the superscript.
What do you mean?
Why make the notation a bit intermediate to understand by making it to go to the superscript?
Later it becomes more convenient because I will be introducing subscripts also. Just try this. Not for the light. For the light it is here. Let's see. We use the light system for the derivation. But those transformations are true for objects which are not light also. Can all of you calculate that using the Lorentz transform? Let me write. So let me write this for you. Dx 1 bar is given by what? Gamma. Okay, is it gamma or lambda? Okay, fine. Gamma dx1 minus we don't talk about dt, just C dt equal to dx. So if you square this, you get gamma square dx1 square plus beta square dx0 square minus 2 beta dx0 dx1. Fine. If you do it similarly, anyways these two don't transform. So write dx can you tell me dx bar 0 square?
Zero gamma
Gamma? What?
oh, minus v by c
Minus
v by c
beta. Ah,
v by c.
let me also replace this with beta.
What is that?
Beta, it is beta.
Okay, minus beta 10 dx.
Fine. Now dx bar square equal to fine. Now subtract this. Is this fine? Is there a minus? There is a mistake. It's fine. And then we have gamma square equal to 1 by 1 minus beta square. Right? This can be written as 1 minus beta square plus beta square by 1 minus. It's not complicated. Beta square minus 1 into gamma square equal to minus 1. Fine. So this will just be beta square minus 1 into gamma square is minus 1. So dx naught square plus dx1 square plus dx2 square plus dx3 square. So if I define it as a quantity ds square and I do some transformation like this, it is still the same. Get it? ds prime square is defined as this. Let's say ds bar square is defined as this in the bar frame. This will be the ds square in the unbarred square, unbarred frame. Got it? So ds is a quantity which is invariant under this kind of transformation. Are there any other transformations which will leave this invariant? Minus 1 also, but something non-trivial.
Like this looks like distance.
How?
Like in a code argumented method, if we define like the distance, it is invariant in both these transformations.
Yeah. And
But there is a minus sign.
yeah, and one of the terms, like if you remove one of the terms, it is just three-dimensional distance.
Yes.
That is invariant under three-dimensional rotations. So even three-dimensional rotations will leave this invariant. So that is what I mean. And yeah, this is the analog of your distance, at least for now. If you want, you can also define dx naught as I dx naught as. So now we can write this as a matrix product, as a vector dot product, right?
Yeah, what is the operator? What was the answer to your question?
Rotational, rotation matrix. This is invariant. Can I also say this is invariant? Minus ds square is also invariant. Fine. I define it as d tau square because it is better to work with in future also. I prefer. So, can I erase this? It is the analog of your distance in three dimensions, but it is something like hyperbolic algebra. So, forget about transformations in y and z. It will be dd square minus dx square. So, spheres are defined as dx square is equal to r square. This is defined as dx square minus dy square equal to r square. The hyperbolic geometry. Now I write can I write this as a dot product of two vectors? So in future you will see that d tau is the time experienced by a object moving. Like we will get to it later. It is complicated. So you can write it as dx0 minus dx1 minus dx2. I mean minus dx3 into dx0 dx1. Fine. So I define this as my new vector this. So these are one is contravariant vector and the other is covariant vector. Like I think this is covariant and this is contravariant.
Why? What is contract?
I am not sure about the literal meanings of those two. So I like in future you will also see that it is better to deal with only these kind of vectors by adding a tensor. I'll show you. Don't worry about the word tensor. So this is called dx mu, right? And this is called dx nu. This one, fine. If I sum over this, I get ds square. Sorry, d tau square. Fine. So this represents this vector, this represents this vector. It is more like the transpose vector. Get it? So like dropping the summation, I can just write like this. Fine. Now, any question? Is there a way to write this in terms of this? Imagine you have a vector ABCD and you want to operate it with a matrix so that the last three objects like BCD will become negative. Diagonal 1 minus 1 minus 1 minus 1. So you multiply with this. You multiply with this. Fine. So this can be written as this. Fine. So when writing this, we usually lower the indices, which mean the same thing. So I meant to say dx I equal to minus dxi, dx 0 equal to dx 0. This thing changes with the book you are using. Some people define it the opposite way. This will become minus and these are just like that. Like they don't change. Now this can be seen as some matrix multiplying with this twice. Sorry, multiplying with twice of this matrix. Let's call this the matrix eta. Just like how we define mu and nu indices here, I'll also define mu and nu indices here. Fine. So, like mu defines the position of the element in row and mu defines in the column. So now I can write d tau square equal to fine. I will actually make a small change to this notation. I mean, this is actually abuse of notation. If I define this, okay, so this is not literally the representation of this, but this is the tensor of this. Like this is a 1 cross 1 matrix. I mean 4 cross 4 matrix. But then, like, just like how I change the indices here, I try to define something like this. The problem arises because the upper indices I defined them as the column matrices, lower indices I defined them as the row matrices. I mean row vector and column vector, and then I am able to write it in a 4 cross 4 matrix. But here, if you want to look at this in a matrix format, I am multiplying two column vectors with something and still getting a scalar. At this point, it is just a summation, right? Summation, product of the components. So numbers compute. So for time being, consider this to be just a object with some indices. Fine. What?
Beta is commute with dx. Like you just change the position.
So dx mu, like so. If I write it in the normal notation, if I write it in the normal like sigma notation, you will be multiplying numbers, right, everywhere. There they can commute. Understand?
One element of the that was the notation we described earlier. Yeah, that is also there.
This is a 2 cross 0 tensor. 1 cross 1 tensor is this. 2 cross 0 tensor is this. Okay, so how did I define a vector? A vector is something which transforms like a vector. A tensor. See, here I defined a vector like is an object with one component. If you try to generalize it for multiple components, it will be a tensor.
Okay, guys, it's 11 now, so is this too much for you? Like, should we need to conclude the thing now?
Sleep cycle is important.
Sleep cycle is important, so yeah. Should we stop it now?
How long total?
Total like how long?
It will take like 20 to 30 minutes more.
20 to 30 minutes more? Okay, sir. Are you sure?
Yeah.
Okay, see, so we can do one thing. I can see that the last part is a bit confusing for a lot of users. So we can do one thing. We can just have a recap of the last part where we can extend the last part afresh, and we can carry on the rest of the part in the next lecture.
Fine.
Or we can just go with the next lecture. Go till the entire content is finished. So which one do you like? Do you guys have a bit of a problem with that eta notation right now? Like,
Okay, so I'll try to redefine it in a
I
easier way.
think what you can do is, I think you can just key in any one of those boards and just explain this last part afresh to them.
Fine.
I think that would be a good take-home message for them right now. Like I can see a lot of them doing that.
Fine. So try to forget about.
Just a second. Who wrote in the teams about the sleeps?
No, Aryan, he's not there.
He's not here. Okay.
Really?
If he were there, then we could have that discussion about when to have the.
No, but he faced problems in the
He
Samasya. He was facing problems in the Samasya lectures.
was wrote in ensemble as well. So we will have a discussion at that. Fine. So Vinay, what you can do is, I think you can just explain this matrix business afresh to them. I think that's
Fine.
they can go home with that, I guess.
Fine. So
Just remove it and like start from the 10 more minutes, guys. Fine. Like it's better if you don't go home confused. Fine. Okay, some of your friends are saying that everything done now till now is clear to them. So I would like to have a show of hands. Like who all are interested in the lecture being continued as it is right?
actually redefine eta properly rather than
And who all want a big recap of the last part? Okay, great.
Fine. So, for a moment, like, remove.
Just like start afresh. That part, just that part.
Okay, fine. So, forget about that up and down notation. In case of vectors, we define it as dx0, dx0, dx1, dx2, dx3 as components of dx mu vector. And when you try to write a contravariant vector, like we are just defining it for the sake of getting that kind of a summation. Fine. You define it as dx0 minus dx1 minus dx2 minus dx3. So this row and column notation is just for a intuitive form of like dot product. So when you do the dot product, this actually means the summation, Einstein summation notation. Fine. So whenever you see a lower and upper indices, unless it is informed, you need to just sum over all of the indices. Fine. So this is technically summation of dx0 minus dx1 plus dx1 minus dx2 plus dx2 minus dx3 plus dx3. Fine. Understood?
Clear till now how the dot product is defined?
Now, like breaking this intuition of row and column matrices, I will try to define something like this. It is just a coefficient with two indices. Just think about it as a coefficient with two indices. Fine? Just like how you write in your matrix products and stuff. This mu like defines the row component of this. Like consider this to be a matrix eta. The name of the matrix is eta. That's it. Don't try to relate the matrix.
If you say that eta and subscript mu, then you are telling, then you are denoting one element of it.
Yeah, the elements of the. So previously when I defined up and lower indices for this, it will be confusing. Don't think about it. So this is the element nu of the matrix. Fine. Now if I multiply and sum with dx mu, got it? What you get is dx mu. It should be the opposite actually.
I guess you get the dual of dx mu. Or dx mu itself.
Yeah. Sorry. Yeah, sorry. My bad. So here I defined something called dx mu. So just don't try to think about it as a vector or something. These are the components of something. So dx mu 0, 1, 2, 3 I get by multiplying this, like summing and multiplying with dx mu. Like, do all of you understand? Any one of you don't understand this? Anyone? So it is just a fancy way of writing matrix multiplying with a vector. Got it? So here I wrote dx mu equal to d tau square. Right, the invariant quantity. Get it? I can replace this dx mu. So there is a summation here also. We will emit the summation later. Like first I emitted writing the coefficients. Now later I will emit that completely. This dx mu will be replaced by this summed product. Do you get it? So this will be a summation of nu. This is a summation of nu because nu is the repeated index. You don't sum over nu. because mu is not the repeated index. Do you understand? So whenever you see a index being repeated twice, up and down, just sum over it. Understand? So summation of mu, eta mu nu, dx mu into dx mu equal to d tau square. Now since there are two summations, there will be two repeated indices, right? So I just write d tau square equal to eta mu nu dx mu dx mu. See, at the level of elements of that dx mu, they are just numbers. So I can always commute, do anything. They are just numbers being summed, right? So now, summation. Okay, so whenever I see two indices being repeated, I sum over them. So in the eta, yeah, unless I specifically tell you that those two are particular elements, it is always sum. I am just doing math stuff, but can I continue with the relativity of simultaneity?
Like everyone, yeah.
If someone has the objection, they will
How
It is enough for today.
long will it take? 10 minutes?
10 minutes. This is a very interesting thing to take home actually. So, you have those transformations, like transformations between two different frames. Assume, like, okay, so to define an event is something which occurs. Like anything which occurs is called an event. So, let's say there are two events with respect to you. With respect to you, there are two events occurring simultaneously. Understand? You understand? Let's say both of this fall simultaneously. With respect to someone running here, will both of them fall simultaneously or not? Why? Okay, so imagine you are on a train going at a speed v. You are inside the train. Fine? And there is a light source exactly in between the train. Let's say the length of the train is 2L. So this is L, this is L. And you are someone who can see everywhere simultaneously. That is the meaning of an observer in relativity. So there is an alarm here, like when this detects a single light pulse or something, it rings. Same thing is here. And you are inside the train. So with respect to you, the light source is just here. And it emits light in two directions. Fine? So light will take how much time to go through? Anyone? What? L by C time. Light will take how much time to go here? So, if your watch is at 0, 0, when the light is being emitted, when your watch shows L by C, both of these alarms will start ringing. Fine? You understand this? Now imagine somebody standing outside the train, seeing the train move. Even for that observer, light still goes at speed of c. So imagine light being emitted at t equal to 0, light is being emitted like this, like light is here. When this moves, this will come closer and this will go farther, but light is still going at speed of light. See, which means this will ring before this will ring. Do you understand? It is very easy to think of this as some manipulation of words, but
in the two pens falling case, where is the source of light?
In that experiment,
it is
in that experiment, it would be simultaneous, like in a moving frame also, right? When the pens were falling.
Only in the
yeah, the pens were falling is just a analogy. Nothing is changing, right? There is no moving frame which I defined. So here, this alarm will ring before this alarm. So who is right? Imagine you are the outside there. Who will say 1, 2, 1 rang before 2, and you are the guy inside. You will say 1 and 2 rang at the same time. But that is the same system, like literally the same thing. How can an event happen with respect to one observer, two events happen simultaneously, but with respect to other it is not?
Time is not.
Fine. Yeah, that is established fact. We call this relativity of simultaneity. Simultaneity. So something which is simultaneous to you need not be simultaneous to someone else moving with respect to you in an inertial frame. Fine. Now consider this problem. You can think about it later also. It is called the bar ladder problem. Let's say you have a hut like this with a door. Fine. And you want to keep a rod or some object with length L in this. But with respect to the bar, when both of these are at rest, with respect to the bar, this has a length greater than this. But now, like somebody who studied relativity just beyond this will say make it go faster. You know why? Somebody who studied relativity just a bit more than this will say make it go faster. Because if you see those transformations, yeah, delta, I mean dx1 dx prime 1 is written as some gamma into dx1 minus beta dx0. Fine. If you are measuring the lengths at the same time difference in unprimed frame is 0. Do you get it? If you are see, dx is just the length of something, right? Dx. If you are measuring the lengths in the unprimed frame, at the same time, like let's say I am measuring this at the same time, the time difference is 0. dx0 is just time into c. So if the S observer in S frame measures the length to be dx1, an observer moving at a speed v with respect to me in an inertial frame will measure the length to be dx bar equal to 1 by root over 1 minus v square by c square dx. So you can never go faster than speed of light, at least physically, as per now. So this is always less than 1. Yeah, give me a moment. Yeah. I think this is fine. better problem than x. It would be better to think about it first.
We are in the prime.
What?
This question, we are in the prime. Like, we are on the ground.
Yeah,
We are in the prime.
exactly. So,
With respect to the rod is always going to be L.
yeah, I will
To us,
rephrase.
the L.
I will rephrase it. So, you have a rod moving at of length L. So, let's say dx. The rod is moving with respect to u at speed v. Sorry. Just consider like this thing, and this is the measurement you make, and this is the actual. Wait a minute.
That's fine because the rod is moving now. Rod will see dx part. So, in the plane of the rod, it is flat, but your plane is dx prime is the moving plane, right?
Yeah.
The rod is moving.
Fine. Yeah, makes sense. So the rod is moving at speed v with respect to u. Fine. And dx prime is the length measured with respect to the rod. You get it? The length of the rod measured with respect to the rod is the actual length of the rod.
Yes.
Understand? So this is the actual length of the rod. So this is the length you are measuring. So the length you are measuring will be the actual length of the rod into 1 minus v square by c square. Get it? So if the rod is moving with respect to you at a speed v, the length you measure of the moving rod will be shrunk in the x direction, in the direction of motion. You understand? So you understand this, right? So imagine you, who studied relativity till now, will come and say to him, just catch this rod, make it move at a speed such that it shrinks with respect to this. So it will fit inside the bar, something. But him will say with respect to him, this will reduce and this will be same.
Over there, yes.
Understand? Do all of you get it?
The bar
So-
will shrink in respect to that plane, no?
See, I'll rephrase this statement. Any moving object, if you observe any moving object which is moving with a constant speed with respect to you, you will, if you measure its length will be less than what it measures by itself. So if you stop it and if you measure it, and if you let it go and if you measure it, the second measurement will always give a lesser value, no matter who is measuring what.
Yeah, but your plane
So do all of you understand this? No matter who you are and what are you measuring, if it is moving with respect to you, its length will shrink with respect to the original length. Get it? So with respect to the person sitting on the bar, will say that the length of the rod will reduce. You get it? But with respect to the person who is moving the rod, will say that the length of the bar will reduce. You get it?
Yes, I
So with respect to this person, you can keep the barn in the, you can keep the rod in the barn. But with respect to this person, you are making it more impossible to keep it. So who is right and who is wrong?
But that house is also moving with respect to that person, right? So it's then
It will shrink even more, right? So the concept is the length of the rod should be somehow made smaller than the length of the barn. But the barn is moving with respect to this guy. Anything which moves with respect to you will only shrink. It will never expand. At least in special relativity. Fine? See, you are not mentioning who is barn, who is ladder. anything which is moving with respect to you will shrink in its size when you measure it. So with respect to the person A, barn should shrink in its size. This is not moving with respect to person A, so this will not shrink. But with respect to this person, this is moving, so this should shrink. Do you all understand the problem? So does this go fit inside the barn or not? Depends on? Okay. Okay, so like it is like a comparison of length, and it should depend on your friend. Fine. Now imagine someone from there will be standing here, and just like you try to push the rod right. Just when this end.
Okay, in that direction, who's it?
Bar. No. That guy is just this guy.
Oh,
Same way. So this, when this touches the edge of the barn, he will drop water on the barn, water on the ladder.
okay.
Fine. If with respect to this person, this shrank much less than this length.
Yes.
So when this touches this, it is already inside.
Yes.
So water don't fall on this. This is wet. Do you understand? So with respect to this person, same person who is standing on the bar, not moving at all with respect to the bar, sitting on the bar, literally sitting on the bar. And according to him, the bar is moving towards him. And since it is moving, its length will shrink. Assuming that the speed is enough for the length to be less than this L0. When this point touches the edge, it will be like something like this. So there is no part of the rod which is outside the bar. So you can't drop water on it. You understand? You agree with me? Fine. Now with respect to this guy is dropping water. But the rod is still outside.
Yes, so it does go.
So does it become wet or does it not become wet?
Mostly it depends on
See, at the end of the day, you all people sit in this classroom and set the rod. It should be wet or it should not be
Yes,
wet.
afterwards, maybe it doesn't become wet because the person dropping water is the same on the ground. So for both of them, the rod touches. Like, for both the people in the ground frame, the rod touches the end of the house at the entire. But because simultaneity is broken in relative frames, for him the rod would have already passed through the wall.
Exactly. So from the relativity of simultaneity with respect to this guy drops water when this touches the wall. Understand? But it not be like these two events need not be simultaneous for this guy. Understand? This guy might drop water when this guy already passed inside.
Yes.
Like assume that this is breakable. Understand?
Instead of the wall breaker now.
What?
Then the wall breaker.
The wall breaks in
No, when the water is being poured, is the wall broken or not?
It is exactly the same statement as touching the wall.
But the wall is in the ground.
Yeah. So do all of you understand the problem? At least, not if not the solution. So does the rod become wet or not become wet? At least I told you two scenarios. In the first one, I explicitly told that both of the events are simultaneous. Right? But did I say that same statement in case of the second one? So, if you see that transformation equations, assuming that everything is just linear in derivatives, delta t bar can be written as gamma into delta t minus beta delta x. Delta t is c multiplied by delta t. So, with respect to this person, this may be 0. This is 0. We are stating that it should be simultaneous with respect to unprimed frame. But delta x is still not 0 because there is some space difference between these two. So, do you understand the solution? Or at least the resolution of the paradox? From this equation, do you see why simultaneity is relative? All of you. So, what exactly does simultaneity mean? Delta t is like time difference between two events, right? Delta x is space difference between two events. Fine? By saying simultaneous, I mean delta t is 0. Fine? But delta t bar in the bar frame, if delta x is non-zero, these need not be simultaneous.
So for the question in the ground frame, the wall breaks after the water is exploded. And the water is put and then the wall breaks. Like for no, for the question in the ground frame.
For the person in the ground frame, water does not fall on the land.
Yeah. And after that the wall breaks. So first the water is poured and then the wall breaks.
Not exactly, because with respect to the person in the ground frame, I define such that the person pours water exactly when the rod touches the wall.
Okay.
So exactly when the rod touches the wall, water falls away. You got it?
Yeah.
These two are simultaneous. So this will be the assignment where. Okay, so this will be the assignment. Let's say this guy is moving with speed v with respect to the bar. All of you. With respect to the bar. Speed v with the rod is moving at a speed v with respect to the bar. Bar, not bar. Yeah. Sorry. So this is a rod and this is a bar. Something, I don't know the extent. So this v is such that the root over 1 minus v square by c square times l. So this is the length this person measures right from this one. Do you get it? All of you. So this is the length at rest. You get it? The length of this rod at rest. But when you move it at a speed v, from this will be the length. So assuming that this is some L0 by 2, you get it? Show that, or let's say L0 plus some delta, where delta is much less than L0. Fine? Fine? You need to show what is the time difference between this rod hitting and this guy pouring in this frame. Do you all get my question? Yeah, we need to find delta.
I had a question, right? In the reference of the person using the rod, the length of the bar is short. So since it is moving in the same velocity, we should have taken less according to the person of the bar. Cross the bar. So according to the person of the bar, the rod might have crossed the bar by that time.
Okay, can you repeat it again?
Yeah, according to the bar, like this is the rod and this bar. According to the person on the bar, like this is short. This length is short. But according to the person on this bar, this house bar length is short. So since it is moving the same velocity, it should take shorter time to cross the bar. Cross the bar. Cross the bar in shorter time. So according to this person, the person is moving water is quite faster. Because it took shorter time according to that person.
It is some kind of a resolution, but the problem is that it's such that there is a connection from this hitting in this point.
It is simultaneous to him, right?
Yeah.
But may not be simultaneous.
Yeah. You understand why it is not simultaneous?
We should delta be less than 0.
Yeah. What?
Delta is less than 0.
Delta of what?
That 1 minus 3 square g square equals.
Oh yeah. Yeah. So the problem to be solved. I'll just take the problem in mind.
Maybe this in the order
No. He gives a time like this. They are model. Then you will get to see it.
You are making them more traumatized than I am. Bro, no time.
Okay, just listen to the problem. That's the last.
Fine. The lengths of the rod and barn are L and L naught at rest. You understand? Now it moves with a speed v towards the barn, such that the length becomes root over 1 minus d square by c square into L. You understand why this comes from there? Yeah. This equal to L naught minus delta greater than 0. Fine. Assume that it is like this. Fine. So the delta is something which is granted for you. L. So L naught is the length of the barn. It should be shorter than the barn. You understand? Fine. So
that equation is actually valid for differential equation. Like, if it is that we differentiated the equation and got dx or equal to gamma dx. It's like bigger length. It's very long, like
So
measurable.
you mean the Lorentz transformations are valid for differential? No, they are valid for coordinates. You take coordinates x, y, z, and d, and the Lorentz transformations are valid for dx. He just did it for dx just to show it, but it's for coordinates in general. When you are talking about length, you subtract two coordinates, right? What is length? Length is the subtraction of two coordinates. The Lorentz transformation works on coordinates. So you have a set of coordinates t, x, y, z that transforms under Lorentz transformation into t prime, x prime, y prime, z prime. Right? Now while you are finding the length, you are finding x prime.
Length is the dot product.
Right.
So it's like a dot product which doesn't change.
So by finding the length, you are finding the difference between two coordinates. So yeah, your question is valid. We showed it here for differential lengths, but it is valid for coordinates in general. While you are transforming from one coordinate to another coordinate, the coordinate transforms to Lorentz transform. Like which part of the proof assume it to be strictly differential lengths? I did not follow it.
so while
Wait.
by the way, while doing the proof, I initially showed it for x0, x1, x2, x3, and then I said if this transforms, then the delta of that should also transform because the equations are linear.
So equations are linear.
You get it? That is a linear equation, right? In vectors.
So
Here, that was.
So here it's written for differential lengths, but as I said, it works for coordinates as well. I think that's how Vinay started at the first place.
Yeah.
The Lorentz transformations act on coordinates from one coordinate to another coordinate, one coordinate system to another coordinate. True? Cool. Did everyone understand the problem that he gave? That you have to think about? The barn and the ladder problem. Fine, everyone? Anyone? Yes. Repeat. Vinay, repeat the problem from scratch, source.
Okay, fine. There is a barn, something like a shelter or something. shed. It has a horizontal length L0. Fine? All of it. There is a shed or barn of horizontal length L0 at rest. Maximum. So there are two people called B and C. I'll tell you their purpose later. And there is one more person called A who is holding a rod of length L when you measure it with respect to the rod. Fine? Now I claim that L is greater than L0. Let's say some L equal to L0 plus some epsilon. Fine? It is X. It can be an arbitrary length. Epsilon greater than 0. Fine? Now the person C says that since when the rod moves with respect to the bar, the length of the rod should reduce with respect to the original length. Do you get it? So if we can go beyond some particular speed, it will shrink more than this. It will shrink less than this. So how much it shrinks is given by this equation. So this doesn't depend on any x. It is a frame dependent quantity, so integrated.
Don't resolve the paradox. Let them think about it. Go read up on it. Think about it.
Yeah. So the person C says making it go at beyond a certain speed will shrink it so that this rod will fit inside this shed. Fine? All this is happening with respect to whom? C and B who are at rest with respect to each other. Now, but the person A will say, since he is going towards the barn is coming towards him with respect to him. Since the barn is moving at the same speed in opposite direction, it should shrink by the same factor. You understand? What? So did all of you understand the paradox here?
Idiots are not allowed to speak.
So let's say this guy moves at a speed v such that the length of this rod, when it is moving with respect to the person C and B, is L square root over 1 minus V square by C square, which is given by L0 minus delta greater than 0. Delta and epsilon are given parameters. You need not find anything. They are already given to you. They are just given numbers. Now, now there is another paradox, but you can say it is just relative. But when this end of the rod hits this end of the wall, the person B will immediately drop water.
End of the wall.
Let me continue. So when C sees that this end of the rod hits this, immediately B will be asked to pour water. Fine? So since with respect to C, this rod is shorter than the barn horizontal length, the rod is completely inside the barn. Fine? So the water doesn't fall on the rod. But with respect to A, fine, the length, the rod hitting the rod hitting the end of the barn and the person dropping the water. Need not be simultaneous. Technically, what this guy will see is that the barn became shorter and the rod stayed at the same length. So the barn can never completely be inside the rod can never completely be inside the barn, which means when this person drops the water, it should fall on the rod, right? So your question is the question to be solved is with respect to A, what is the time difference, if it exists, between the rod end hitting the bar end and the person B dropping the water, given that this person B exists at length L0 with respect to the. You understand?
Then I think it's fine. Like we can let them think about it, the entire problem.
Yeah.
Guys, I would like to add a little thing here, what he told about these transformations, okay? Just a small thing here. So, dx is your vector here, okay? Guys, एक बार ये सुन लो please, वो करते रहना तुम, बान paradox please. Yeah, ये तो मैं थोड़ा, अगर तुम सुनोगे नहीं तो तुम बहुत confused हो जाओगे बाद में. dx is the vector, okay? इसके its components are dx mu. dx mu is not the vector itself. Dx is a vector, its components are dx mu, and mu is 0, 1, 2, 3. Mu is just a fancy way of writing, it is 0 also, it is 1 also, 2, 3, okay? So this is just a fancy way of writing dx0, dx1, dx2, dx3, okay? Now what we are doing here, so this equation, this is a fancy way of writing 4 different equations together. So, this thing is sum over mu runs from 0, 1, 2, 3, 4, and this is true for mu equal to 0, mu equal to 1, mu equal to 2, mu equal to 3. So for mu equal to 0, this equation says eta 0, 0, dx 0 plus eta 0, 1, dx1 plus eta 0, 2, dx2 plus eta 0, 3, dx3 equal to dx 0, okay? What this equation says is this thing for mu equal to 0. Similarly, you can write another equation for mu equal to 1, another for mu equal to 2, another for mu equal to 3. This is just a very fancy way of writing 4 different equations together. And we omit this summation sign here, the Einstein convention notation, okay? Now, if you observe this equation closely, you will see that this is exactly the same equation we get by multiplying these things. Suppose you have a matrix with components eta 0, 0, eta 0, 1, eta 0, 2, eta 0, 3, eta 1, 0, 2, 0, and so on, dx0, dx1, dx2, dx3. This is this thing.
You can literally check, like, you will get 4 equations and those 4 equations will
You can see that this thing and these 4 equations are the same thing. Can you see that? Just multiply this thing here, eta 0, 0, dx0 plus eta 0, 1, dx1. You got my point, right?
Yeah.
So, this is eta, this complete matrix eta into a vector dx is equal to another vector, another co-vector here, which I have like write some other notation for it, not dx. So, this is a matrix and this complete thing is a vector. This multiplied gives the makes this 0 from a vector to a co-vector, or this indice goes down. Okay?
So
You got my point?
4
So-
linear equations, you can represent them as a matrix equation like that, or you can represent them in a fancy way.
So this complete thing is just equivalent to writing this equation. Like remove the sigma, because if 2 indices are same up and down, that means it is automatically summed. So you can write either this whole thing or you can write just this equation. That is why we use Einstein summation. It is very compact way.
But please note, while you are writing eta mu or dx mu or anything, those things are just numbers.
Yeah,
Those
these are just component here. So this is this thing, like this thing. So this is just a number. This is not a vector or a matrix complete thing. This is just a component of a 4 cross 4 matrix. There are 16 of these things. There are 4 of these things. There are 4 of these things. You got my point, right?
Cool. You got that point. Now, what you have to do is you have to go back and read about those paradoxes that we mentioned. Because unless and until you read it yourself once, you won't be able to get the entire picture. And we can have a discussion on the open problem that you gave in the next class. If anyone still have any doubts or any discussions, they can come to the board and talk to us. And rest of the lecture are open.
Oh, wait.
One thing.
Next lecture when?
Yes. Should we have lectures in the evening from 6 or from 9? बंद कर दे